Okay, let's think of the probability of 2 boys, 3 girls out of 5 kids. Okay, assuming the probability of a boy on any birth is 1/2, the probability of a girl is also 1/2. Can you apply the binomial probability analysis to this situation? You should stop and think about that. Now, the question that came up in class when I let people think about this a little bit was, well, is having a boy a success or is having a girl a success? That's an excellent question because that goes right to the heart of it. You look at the condition and you have to figure out how many successes are going to happen out of how many trials. And you could do this either way. You could consider a girl to be a success or you could consider a boy to be a success. So we're going to do it both ways. Okay, first one, if a girl is a success, then what's P? P is the probability of a success. Well, probability of a girl is 1/2. Then a failure would be a boy. Okay, you don't want to take that too literally, but what's the probability of a failure? Q is the probability of a failure. It's 1 minus the probability of success, which is, since the probability of a success is 1/2, the probability of a failure is also 1/2. How many successes? Well, 3 girls out of 5 kids. R would be 3. How many trials? Well, you got 5 kids. That's 5 trials. N equals 5. So the probability is going to be C of 5, 3. Number of ways of distributing the 3 girls. And, do you have girl, 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 boy, boy, girl, boy, girl, boy, girl? How many ways are there to do that? Well, it's C of 5, 3. It turns out to be 10 possible ways the girls could be distributed among the 5 births. And then you multiply that by P to the 3rd, P to the number of successes, probability of success raised to the number of successes, because for each success you have to multiply by the 1/2. And then probability of a failure multiplied by itself, which is or by the number raised to the power of the number of failures, which would be 2. So there's your application of the formula to this situation if a girl is a success. If a boy is considered to be a success, then, well, same thing, except there are only 2 successes because you're only getting 2 boys out of 5 kids, 5 births. And the same reasoning holds, except that you're going to have C of 5, 2 instead of C of 5, 3, because you're only distributing 2 boys, 2 male births out of the 5 possible. 1/2 raised to the R, well, R is only 2, so you're going to get 1/2 to the 2 instead of 1/2 to the 3. And Q raised to the N minus R power. In other words, probability of a failure is 1/2 raised to the power of 3, because there's going to be 3 failures corresponding to 3 births that aren't boys. Okay. Now, this expression looks a lot like this expression, except you got the 2 here and the 3 here. Now, 1/2 to the 3rd times 1/2 squared, well, you're going to have 1/2 to the 5th. And 1/2 squared times 1/2 cubed, well, that's 1/2 to the 5th. That's the same both ways. But what about C of 5, 3 and C of 5, 2? Well, if we calculate them, C of 5, 3 is 10. C of 5, 2 is 10. You can write out and analyze the expressions for these probabilities, and you'll see that they come out exactly the same. Also, the N equals 5 row Pascal's triangle reads 1, 5, 10, 10, 5, 1. Here's your C of 5, 2. Here's your C of 5, 3. They're equal. So these are equal since C of 5, 2 and C of 5, 3 are equal. And you would, of course, hope that it would be equal because it's the same. You're analyzing the same probability, just 2 different ways. Probability doesn't change because of the way you analyze it. So the probability could be expressed either this way or this way. Okay, there's another example, and I'm going to build that one a little more length, so we'll do that in another clip.